Good afternoon. As I said, I would not be able to be here today, so we're going to watch a quick video, or you guys are going to watch a quick video that just covers the rest of the notes from yesterday, and then in addition to 3 examples that you should have picked up on your way in today. Again, sorry, the numbers are a little off. Today's note should be 4.11 pre-AP notes, day 2, but instead they say 412. So again, what we are doing is we are solving these polynomials. So for some of us, we've already gone through 6th and 7th. But what we were talking about is we had the rational root theorem, which told us the list of possible roots. And what we were doing is we were testing those roots using the remainder theorem, which said that if we were to plug the solution into the equation, that we could check to see what type of answer we would get. And that final number that we get is actually the remainder. And so what we're trying to do is we're trying to plug in numbers that would give us a remainder of 0. So if we look at number 6, they are giving us the problem, and we are dividing that by b minus 7, which, as you guys would know, the solution to would be b equals 7. So what we're going to do is we're going to plug 7 into the equation. So we would have 7 to the 4th minus 8 times 7 cubed minus 7 squared plus 62 times 7 minus 34. And so what we want to do is we want to see what this gives us when we simplify it out completely. And what we're hoping to get is a 0, because that would mean that b minus 7 is a factor. But if it's not a 0, then we would know that it's not a factor. So when we put all this in, we get is b equal to 8, which means that unfortunately this would not be a factor. So this is not a factor. All right, so then we could try number 7, which they're asking is x minus 2 a factor. So then we would get the solution, which would be x is equal to 2. And once again, we're going to plug that into the equation for number 7. So that would be 2 to the 4th minus 8 times 2 cubed plus 8 times 2 squared plus 2 times 2 plus 4. All right, and when we put all that in our calculator, we get 0. Which means that x minus 2 would divide in evenly into the problem x to the 4th minus 8x cubed plus 10x squared plus 2x plus 4. So yes, this is a factor. All right, so now what we're going to do is we're going to use that to help us with the next couple examples. So if you guys will go to the next page. All right, so looking at number 8. So once again, they haven't given us a factor yet. Which means we have to come up with the factors on our own. So from the rational root theorem, we can get a list of possible factors, which again is the p over q. Factors of the constant, which is p, over factors of the coefficient, or leading coefficient, which is q. So for the factors of the constant, which is 3, it'd be plus minus 1 and plus minus 3, divided by factors of the leading coefficient, which is again plus minus 1. So we have the option of either a positive 1, negative 1, positive 3, or negative 3 working or dividing evenly into the factor. So now what we can do is we can test one of these points to see if synthetic division will actually even work. So let's start with 1. So this would be 1 cubed, which is 1, minus 5 times 1 squared, which is still just going to give me 5, plus 7 times 1, which is 7, and then minus 3. All right, so then if I look at this, I've got 1 and 7, which is 8. Negative 5 and negative 3 is a negative 8, which gives me a 0. So I know that we tested 1, so this is testing 1. That 1 went into this evenly because the remainder gave me a 0. So now we can use synthetic division with a 1. So now we'll use the synthetic division using 1 to break this down into something that is factorable. So 1, remember, always drop down the first term, which is 1. 1 times 1 is 1, minus 5 is a negative 4, times 1 is negative 4, which gives me 3, times 1 is 3, and 3 minus 3 is 0. So we know that that divided in evenly. So we started with a x to the 3rd, which means that this will be x squared minus 4x plus 3. So now what we just need to do is factor this fully so that we can solve. So we would factor this down into factors of 3 that would subtract to get you a -4 would give me -1 and -3. So this is x minus 1 and x minus 3. So once again, this is a cubic, which means we should have 3 factors. So we had the x minus 1 and the x minus 3. And remember that we used +1 as a divider. So that meant the solution was x equals 1. So the factor would be subtract 1, so we get the factor of x minus 1, which means x minus 1 is actually a double root. So our factored out equation would be x, this is pretty light, let's see, x minus 1 squared times x minus 3. So for the solutions, we would get that x is equal to 1 and x is equal to -3. Okay, let's look at number 2. Once again, they have the synthetic division set up, but we do not know what any factors are to start with. So we will have to come up with a list of our own. So again, P over Q. Factors of the constant, which is 10, would be plus minus 1, plus minus 2, plus minus 5, plus minus 10. And that would be divided by the factors of the leading coefficient, which is just plus minus 1. All right, so again, any of these values are possibilities, but we should only have 3 factors because that is x cubed. So let's test 1. Well, that's where we should pretty much always start. And so if I did 1, if I plug that into the equation, that would be 1 cubed, which is 1, minus 6 times 1 squared, which is still just a -6, plus 3 times 1 is 3, plus 10. All right, and so what I get here is, let's see, 10 plus 3 is 13, plus 1 is 14. 14 minus 6 is definitely not 0, so 1 did not work. All right, so let's try a -1. So if I try -1, so this was trying 1. So if I try -1, I would have -1 cubed, which is -1. And then -6 times -1 squared, so that would give me a -6. Minus or plus 3 times a -1, so that'd be minus 3, and then we have plus 10. So now I have -1 and -6, which is a -7, minus 3, which is a -10, plus 10 gives me 0. So I know that -1 is a solution to this, which means that I can use -1 for synthetic division to break this down into something that is factorable. All right, so do my synthetic division, bring down the 1. All right, so I guess I keep writing this line in the wrong place. So we bring down the 1. 1 times a -1 is a -1. -6 and -1 is -7. -7 times -1 is 7. Plus 3 is 10. Times a -1 is -10, which gives me a remainder of 0. Again, if these are factors, you should always get a 0 remainder. So now I am left with x squared minus 7x plus 10, which we can then factor down into factors of 10. That will give me a -5, would be 5 and 2, and they would both be negative. So -5 and -2. So then I have the factors of x minus 5, x minus 2. Once again, -1 was the solution, so this would be x equals -1, add 1 to both sides, so we get a factor of x plus 1. All right, so this is the fully factored form of the polynomial that we were given. So then for the solutions, that would just be x is equal to 5, x is equal to 2, and x is equal to -1. Okay, now if you will get out the half sheet that says 4.12 pre-AP notes day 2, again, this is still part of 411. So we'll do 4.12 on Friday. Tomorrow, that is the writing portion. Now, these problems that we're being handed here, these are going to be a little bit more complicated than what we just looked at. So if we look at this, once again, we're looking at a 4-term, so we want to use synthetic division to divide this into something, or hopefully simplify this into something that is factorable. Because if we try to use grouping right now, that wouldn't work, because we have a 6 and a 7, and there's no way that we're going to make that match with a 9 and a 2. So we're going to have to use synthetic to make this work. So again, P over Q to get a list of all the factors. And so we would get, for the constant, it would be plus minus 1 and plus minus 2 divided by the leading coefficient, which would be plus minus 1, plus minus 2, plus minus 3, and plus minus 6. All right, so again, this is the list of all the possible factors. And so what we want to do is we want to just test these to see which one would work. So let's start with 1. All right, so let's try plugging in 1 and see if we get a remainder. So if I plug in a 1, let's see, that would give me 6 minus 7 minus 9 minus 2, which is obviously not going to be 0, so that didn't work. So now let's try negative 1. So negative 1 cubed is still negative 1 times 6, so that would give me a negative 6. And then negative 1 squared is 1 times negative 7 is negative 7. Negative 1 times negative 9 is a positive 9, and then we have negative 2. All right, and once again, negative 7 and negative 2 would give me negative 9. Plus 9 would give me 0, but we would still have a negative 6 left over. So this one does not work either. So let's keep going, and let's try with 2. So if I try 2, that would be 6 times 8 minus 7 times 4 minus 9 times 2 minus 2. Now, when I put this in my calculator to simplify, we get 0, which means that 2 is a solution to the polynomial. All right, so if 2 is the solution, so x is equal to 2, then that means that x minus 2 would have to be one of the factors. All right, and remember that we should be expecting 3 because it's a cubic. So we know that x minus 2 is one of them because the positive 2, which was the solution, divided it evenly. So now we'll use our synthetic division to break this down. So we have 2, which gives me 6, negative 7, negative 9, negative 2. And we'll drop down the first number, which is 6. 6 times negative 2 is 12, minus 7 is 5. Times 2 is 10, minus 9 is 1, 1 times 2 is 2, minus 2 is 0. All right, so now I have 6x squared plus 5x plus 1, which we will have to factor. So multiply a and c, 6 times 1 is 6. So I need two numbers that are going to multiply to give me 6, but are going to have to add to give me 5. And those two numbers are 3 and 2. Now, you would want to use grouping on this because you do have a coefficient of a 6 in front of the x squared. So we'll expand this into 6x squared plus 3x plus 2x plus 1. And then we need to factor by grouping. So we'll factor to the first 2 and the second 2. So the GCF in the first set is 3x, which gives me a factor of, or leaves me with 2x plus 1. GCF in the first one is just going to be 1, and that would be 2x plus 1. And so now I get the two factors of 3x plus 1 and 2x plus 1. Okay, and sorry, this is kind of a little messy. I don't think I can move this down, can I? Nope. Okay. So now what we want to do is find the solution. So we have the two factors that we just found from factoring, plus we have the x minus 2 that we found from the rational root theorem. So then we're going to get our three solutions. So if x minus 2 is the factor, then x would equal 2 for the solution. If 3x plus 1 is the factor, so setting that equal to 0, subtract 1, divide by 3, so x would equal 1, negative 1/3. And then the next one, set that equal to 0 as well. So you would subtract 1, divide by 2, so x is equal to a negative 1/2. All right, so 3 roots, 3 solutions for something that it was to the third power. Again, remember, the number of solutions should match the highest degree that you have. Okay, now let's look at number 2. when we look at number 2, we should see that they all have an x in common. So whether you do it at the beginning or whether you do it at the end, we can go ahead and factor out a GCF of an x. So I'm going to go ahead and take out the x now, which will give me x cubed minus 13x squared plus 55x minus 91. All right, and now remember that this is an x to the 4th, which means we should have 4 factors. So we factored out a GCF of x, and so x is the first factor. So there's one of them. All right, and now with synthetic division, unfortunately, you can't use 0 as a factor, because either way, you're still going to get a 0 at the end. So we're going to have to find a different number in order to start the synthetic division, because we're not going to be able to get this to divide using grouping, or simplify or factor using grouping. So now we can look at all the different options for P over Q. So the factors of 91 are plus minus 1, plus minus 7, plus minus 13, and then plus minus 91. And that's all divided by Q, which is again plus minus 1. So what we want to do is we want to test some of these numbers to see if they will divide in evenly. So using that remainder theorem, let's start plugging in 1. So if I plug 1 into this equation, 1 cubed is 1, minus 13x squared, so that would be minus 13, plus 55 minus 91. All right, and now 55 and 1 would give me 56, which there's no way that's going to cancel out a negative 91. So 1 unfortunately did not work. So now we can try negative 1. So if I try negative 1, then I could get negative 1 cubed, which is negative 1, and then negative 1 squared is 1 times a negative 13 is negative 13. And then that would be negative 1 times 55, which is a negative 55, and that would be negative 91. All right, and so now we can see that all of these are negative, which means there's no way that we're also going to be able to get to a 0. So negative 1 is also not a solution. So now our next one would be a positive 7. So let's try 7. All right, now this one I would probably do in your calculator because ones are nice and easy, but this is going to be a little longer. So this would be 7 cubed minus 13 times 7 squared plus 55 times 7, and then minus 91. And now when we put all this in our calculator, we actually do wind up getting 0 as an answer, which means that this will divide in evenly. So keep in mind, x equal to 7 is the solution. So we subtract 7 from both sides, so that way we can get the factor of, oops, get my pen back here, x minus 7. So now we have 2. Again, we should expect 4. So let's use our new root, and let's go ahead and use synthetic division to get this into something that is hopefully factorable. So then we'll use 7 out here, and then that would be 1, negative 13, 55, and negative 91. And we'll do our synthetic division. So you bring down 1. 1 times 7 is 7. Minus 13 is a negative 6. Times 7 is negative 42. Plus 55 is 13. 13 times 7 is 91, which gives me a remainder of 0. So I'm left with x squared minus 6x plus 13. So factoring, we would need two numbers that are going to multiply to give me 13, but are going to add to give me negative 6. Now the only numbers that are going to multiply to give you 13 are 1 and 13. And there is no way, whether we're adding or subtracting, that we're ever going to get a 6. So what happens is this is not factorable. Doesn't mean we cannot find the roots, but it is not factorable. So now we're going to have to go back to way older Algebra 2 stuff, and we're going to have to figure out what are the solutions to this. So to do this, you have a couple of different options. We can solve by completing the square, which was never really one of our favorites, or we could use the quadratic formula. Those were the ones that can solve things that were unfactorable. So let's go back to quadratic formula. All right, remember it's negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So if I plug this in, then I would have, let's see, a is 1, b is negative 6, and c is 13. So if I plug this in, then I would have negative b. So b is also already negative, so the double negatives are going to make that into a positive 6, plus or minus the square root of 36, because of b squared, so 36, minus 4ac, so that would be 4 times 1 times 13, which is a negative 52. There we go. And that would be divided by 2 times a, which a is 1, so this is just divided by 2. All right, so now keep on simplifying. So we've got 6 plus or minus 36 minus 52 is a negative 16, and that again is all divided by 2. And so now we have a square root of negative. So what's happening here is we have imaginary solutions or imaginary roots. So then I could get 6 plus or minus, the square root of a negative 16 would be 4i, and that's divided by 2. So when we simplify, we would get 3 plus or minus 2i. So remember, we're solving these. So 3 plus or minus 2i is one of the solutions. We had x as a factor, which means that 0 is also a solution. Then we had, this was a 7, x minus 7 as a factor, which means 7 is a solution. All right, so again, this was x to the 4th, meaning we should have 4 solutions. This will be 3 plus 2i is one of them, 3 minus 2i is the second, 0 is the third, and 7 is the fourth. All right, so what I want you guys to do is I want you to try to work out number 3, which you can check the key either with the sub that I've left it with, or you guys can go on to Canvas and check your key there. With number 3, this is non-factorable at the very end, so you guys are going to have to use either quadratic formula or completing the square in order to find the other solutions. Again, I'll answer any questions that you guys have over any of this tomorrow in class. Keep in mind that your test is on Tuesday, and you should have picked up a review in class today. So after that is done, or after this is done, I want you guys to go ahead and start working on the review. Again, any questions, make sure you bring them to class with you tomorrow, and we'll discuss anything you need to discuss. Hope you have a good day. See you tomorrow.